This video is going to continue our lesson on solving inequalities. We're going to finish up that note paper, and then it's also going to turn into some practice. So to get started, we're going to solve this inequality. Nice, simple one-step inequality. Make sure you're using your notes from the last video. Pause the recording now so that you get that completed and we can check our answers. From our lesson yesterday, we know that we can solve an inequality in the same ways that we would solve an equation, where we make a flow map. What's happening to x? X is being multiplied by a negative 11. How am I going to undo multiplying by a negative 11? Dividing by a negative 11. So I'm going to divide by a negative 11, and whatever I do to one side, I do to the other side. A negative 11 divided by a negative 11 divides out, and it leaves me with just x. A negative 77 divided by a negative 11 is a positive 7. And from yesterday's lesson, you should have realized that when we divide by a negative, that is a reflection over the number line. So this less than symbol is going to be reflected to be a greater than symbol. We have to reflect or flip the inequality. The correct answer, what you should have typed into your calculator, is 7 is greater than x. What does that look like in our calculator? I know, you weren't the only one. In order to access the inequality symbols, you will see above your calculator, above the equal sign on your calculator in yellow, my screen it's blue, that's the inequality symbols. So if I wanted to type in x is greater than, I have to go control and then the equal sign, there's all of my inequality symbols. X is greater than, or it was 7 is greater than x, right? 7 is greater than x. Please share with your groups what your mistake was. Talk with your groups. There was lots of mistakes, so please share. Not going to pause the recording. We're going to give them a chance to talk. That way you can think about your own mistake. Okay, voice is off. Raise your hand if you forgot to flip the symbol. There was only a handful of those. Raise your hand if you forgot that a negative divided by a negative is a positive. There was more of you than that. I know. I'm seeing your answers. Raise your hand if you just didn't pay attention yesterday and didn't know at all what we should be doing. Yeah, there was a few of those too. So what I need you to do now is, we saw in this inequality, we ended up flipping or reflecting that inequality. What was less than had to change to greater than. Today we're going to see more of why that's necessary, but before we even do that, review your notes and talk with your groups. When do I need to flip the inequality? We did write a rule. Review that. When do I need to flip the inequality? Talk with your groups. And voice is off. What conclusion you should have come to is multiplying or dividing by a negative number is a reflection. So if I'm multiplying by a negative number, if I'm dividing by a negative number, that's when I need to reflect. We also wrote it here in our summary. When we multiply or divide by a negative, we're going to add a statement here. So make sure you're on the right spot on your notes. When we multiply or divide by a negative, when solving, it is a reflection over 0. So everything, including that comparison symbol or that inequality symbol, is also reflected. Simply put, we flip the inequality. We put this to practice with just one single problem yesterday. We solved it correctly. We remembered to flip the inequality before we solve it incorrectly, because you should have done that for your homework. Before we solve it incorrectly, I want us to review and check our answer, okay? So when it was equations, we could check our answer because it was like x equals -4. So I could take that -4 and I could just plug it in for x. But it's not equal to -4. In fact, this inequality specifically tells us that it's not -4, it's everything that's less than -4. So what you do need to do to check your answer is pick something that's shaded. Pick something that is smaller than -4, like this number right here. -6 is shaded. -6 is a number that's smaller than -4, so when I plug in this number here into the original inequality, it should give me a true statement. Let's test it out. So again, -2x is now -2 times a -6. We're subtracting 1, and that should be greater than 7. So we're plugging it back into the original. -2 times -6 is a positive 12. 12 minus 1, is that greater than 7? Yeah, so it does check out. I should have backed up. I should have shown how one of the reasons I chose -6 is because plugging it into the solution is also true. Is -6 less than -4? Yeah, so it starts off a true statement here. That's why I can take that -6, plug it into the beginning here, simplify, and I get a true statement. So isn't that interesting? I plug it in here where it's less than, plug it into the beginning where it's greater than, and it still gives a true statement. Now let's solve this incorrectly, and I do want us to label this because we're going to do this multiple times. This is done correctly. Please label it as correct. This is done incorrectly. We can learn from mistakes, so we are going to make the mistake so that you can see why this is necessary. So for your homework, you should have already solved this. Yes, Tage?
So you said it solve it as incorrectly as possible, right?
No, not as incorrectly as possible using one specific mistake. I told you don't flip the inequality. That's why we're going to solve it using that one mistake. I'm going to add 1 to each side, just like I did the first time. You should be doing this with me, not talking over me. Adding 1 zeroes out the subtracting 1. So I have -2x is greater than 7 plus 1 is 8. The next step, still going to use that same flow map. We're just dividing each side by a -2. However, even though I'm dividing by a negative, and the rule says I need to flip it, let's make the mistake where we don't flip it. X is greater than 8 divided by -2 is -4. Let's graph this solution. Check our answer by plugging something in. So x is greater than -4, which means I'm still going to do an open circle on -4. -4 is not going to work, but all the numbers that are greater than -4 should work. So -3 is greater, -2 is greater. All of these are numbers that are greater than -4. So just like before, I'm going to pick something that's shaded. Let's pick, how about the number 3? You guys okay with 3? It's shaded. So pretending like I don't know that I made a mistake, I'm going to check this, plug it back in, and it should give me a correct answer. So what I'm saying is 3 is indeed greater than -4. Do you agree with that statement? Yeah, 3 is greater than -4. So I'm going to take that 3 and plug it in for x. X changes to a 3, so -2 times x, but now I'm substituting in 3, minus 1 is greater than 7. -2 times 3 is -6, minus 1 Negative 6 minus 1 is negative 7. Is negative 7 greater than 7? No, this is a lie. This is false. It all comes down to when we divide or multiply by a negative number somewhere in our solving process, we have to flip that inequality in order to keep that equality true, because everything else is being reflected. The inequality symbol also must be reflected. What questions do you have? You've seen it correctly, you've seen it incorrectly. What questions do you have? Are you ready to practice it some more? Okay. Do you think you're ready to give it a try with your groups, or do you still need some guidance? Groups? Okay. You guys do it with your groups. As these students do it with their groups, I'm still going to guide on the video. I'm not going to talk through the video, but I am going to guide through the video. So if you're stuck, you can watch the video and see what's happening. Okay, with your groups, and I'm silently guiding on the video. Ready, set, go. Okay, voices off, please. Check your answer. Make sure you do both parts. Make sure you solve. You have your statement, x is less than negative 12, because I remembered to flip my inequality. I multiplied by a negative, so I flipped the inequality. I graphed it with an open circle, and I shaded all of the numbers that are smaller or less than negative 12. What questions do you have? Okay. I feel like I've illustrated with this example why we need to flip. We did it correctly where we flipped. We did it incorrectly where we did not flip. Do you need me to do this one incorrectly? I'm going to let you guys be the judge. No one wants it incorrectly, right? Okay, then we don't have to do this again. Notice it's the exact same problem. I just gave you the option to do it incorrectly. If you already did it, great. If you didn't do it, also great. Just let's go ahead and label this. This one is correct. Since we labeled the other ones, label this one as done correctly. And we have some more. Yes, Brock. Yeah, if you feel like doing it incorrectly is going to help you see the differences, if you're going to take the time to plug in your solution and check your answer, then doing it correctly and incorrectly is probably a good thing. But I don't want you to build a habit of doing it incorrectly. And I don't know if you guys are going to take the time to check your answers. Does that make sense? Doing it incorrectly only has value if you're checking your answer. So while we're saying that, why don't we check our answer here where we've done it correctly? What is a number that's less than negative 12? What is something that's shaded? Sam, let's plug it in. Do you agree with the statement where I'm just plugging in negative 15 for x? Is negative 15 less than negative 12? That's a true statement. So I'm hoping that when I plug it back into the original, I'll also get a true statement. Negative 15 divided by negative 2 plus 4, is that greater than 10? You actually even have your calculators. So we can test this out in our calculators. Let's take a look and see what that would look like. Negative 15. Oops, hold on. Let me try again. Negative 15 divided by negative 2 I forgot already. Help me out. Was it plus 4? Plus 4. And that should be, I forgot again. I need to look. Greater than 10. Control equals pulls up those inequality symbols. Is that greater than 10? I'm going to press enter and it's going to tell me yes, that is a true statement. So flipping that inequality did help us get the correct answer. Please, before we move on to these ones, I know some of you are already working ahead. Stop and listen. Put your pencils down. Listen. Please review one more time with your group. When do I flip or when do I reflect that inequality? Talk with your groups one last time. Okay. And voice is off. Let's try that again. Voice is off. Thank you. When do I need to flip or reflect that inequality? Good. Happy to see these hands. Emery. Careful. Not always if there's a negative involved, as we're going to be seeing in some of the next set of problems that I have for you. So when specifically, sometimes a negative is involved, but we have to be careful about that. Let's go to Gracie. Yes, so not just when a negative is involved, but specifically if I'm going to be multiplying by a negative or dividing by a negative. What if I add a negative? That doesn't matter. I didn't say it's not multiplying or dividing. What if I subtract a negative? No, because it's not multiplying or dividing. So let's take a look at this one. Make a prediction just based on the structure. Am I going to need to reflect the inequality at some point in the solving process? Talk with your groups and form a plan.
What's our plan, group?
I'm going to pause the recording as they discuss. 2x minus 1 is greater than 7. Am I going to need to flip the inequality at any point in this equation? Inequality, I'm sorry. No, because it's not being multiplied or divided by a negative. So my solving steps, although it's going to include division, it's not going to include dividing by a negative. So those solving steps would be, add 1 to each side, giving me 2x. Symbol comes straight down, is greater than 7 plus 1 is 8. Next solving step, I'm dividing by 2. That leaves me with x is greater than 4. Notice I didn't flip the inequality. Yes, I divided. I did not divide by a negative. So the inequality does not change. X is greater than 4. That means, and I gave lots of greater thans because this is where students forget, greater than 4 means it's not 4, but it is all of the other numbers that are greater than 4, that are bigger than 4. So make sure you're in the habit of graphing, doing the shading, paying close attention to whether it's going to be an open circle or a closed circle. And the last one, x divided by 2 plus 4 is greater than 10. My solving steps here include subtracting 4 from each side, leaving me with x divided by 2 is greater than 10 minus 4 is 6. I then am going to multiply each side by 2. So yes, I'm multiplying, but I'm not multiplying by a negative. So I end up with x is greater than 12. Again, an open circle on 12 because it's not 12, but it is all the numbers greater than or bigger than 12. So I'm shading all of those bigger than 12. This is the end of this video. I do have practice problems, but I'm going to include that in a separate video. So if you want more practice with this, make sure you check out the next video on solving inequalities. Thanks for watching. We'll see you next time.